This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recorded by Annie Coleman in St. Louis, Missouri in April 2006. The Origin of Species by Means of Natural Selection, or The Preservation of Favored Races and the Struggle for Life, 6th London edition, by Charles Darwin. Chapter 1, Part B. Breeds of the Domestic Pigeon, Their Differences and Origin. Believing that it is always best to study some special group, I have, after deliberation, taken up domestic pigeons. I have kept every breed which I could purchase or obtain, and have been most kindly favored with skins from several quarters of the world, more especially by the Honorable W. Elliot from India, and by the Honorable C. Murray from Persia. Many treatises in different languages have been published on pigeons, and some of them are very important, as being of considerable antiquity. I have associated with several eminent fanciers, and have been permitted to join 2 of the London pigeon clubs. The diversity of the breeds is something astonishing. Compare the English carrier and the short-faced tumbler, and see the wonderful difference in their beaks, entailing corresponding differences in their skulls. The carrier, more especially the male bird, is also remarkable from the wonderful development of the carunculated skin about the head, and this is accompanied by greatly elongated eyelids, very large external orifices to the nostrils, and a wide gape of mouth. The short-faced tumbler has a beak in outline almost like that of a finch, and the common tumbler has the singular inherited habit of flying at a great height in a compact flock, and tumbling in the air head over heels. The runt is a bird of great size, with long, massive beak and large feet. Some of the sub-breeds of runts have very long necks, others have very long wings and tails, others singularly short tails. The barb is allied to the carrier, but instead of a long beak has a very short and broad one. The pouter has a much elongated body, wings, and legs, and its enormously developed crop, which it glories in inflating, may well excite astonishment and even laughter. The turbot has a short and conical beak, with a line of reversed feathers down the breast, and it has the habit of continually expanding slightly the upper part of the esophagus. The Jacobin has the feathers so much reversed along the back of the neck that they form a hood, and it has, proportionally to its size, elongated wings and tail feathers. The trumpeter and laugher, as their names express, utter a very different coo from the other breeds. The fantail has 30 or even 40 tail feathers instead of 12 or 14, the normal number in all the members of the great pigeon family. These feathers are kept expanded, and are carried so erect that in good birds the head and tail touch, the oil gland is quite aborted. Several other less distinct breeds might be specified. In the skeletons of the several breeds, the development of the bones of the face, in length and breadth and curvature, differs enormously. The shape, as well as the breadth and length of the ramus of the lower jaw, varies in a highly remarkable manner. The caudal and sacral vertebrae vary in number, as does the number of the ribs, together with their relative breadth and the presence of processes. The size and shapes of the apertures in the sternum are highly variable. So is the degree of divergence and relative size of the 2 arms of the furcula. The proportional width of the gape of mouth, the proportional length of the eyelids, of the orifice of the nostrils, of the tongue, not always in strict correlation with the length of beak, the size of the crop and of the upper part of the esophagus, the development and abortion of the oil gland, the number of the primary wing and caudal feathers, the relative length of the wing and tail to each other and to the body, the relative length of the leg and foot, the number of scutelli on the toes, the development of skin between the toes, are all points of structure which are variable. The period at which the perfect plumage is acquired varies, as does the state of the down with which the nestling birds are clothed when hatched. The shape and size of the eggs vary, the manner of flight, and in some breeds the voice and disposition, differ remarkably. Lastly, in certain breeds, the males and females have come to differ in a slight degree from each other. Altogether, at least a score of pigeons might be chosen, which, if shown to an ornithologist, and he were told that they were wild birds, would certainly be ranked by him as well-defined species. Moreover, I do not believe that any ornithologist would in this case place the English carrier, the short-faced tumbler, the runt, the barb, pouter, and fantail in the same genus, more especially as in each of these breeds several truly inherited sub-breeds, or species as he would call them, could be shown him. Great as are the differences between the breeds of the pigeon, I am fully convinced that the common opinion of naturalists is correct, namely, that all are descended from the rock pigeon, Columba livia, including under this term several geographical races or subspecies, which differ from each other in the most trifling respects. As several of the reasons which have led me to this belief are in some degree applicable in other cases, I will here briefly give them. If the several breeds are not varieties, and have not proceeded from the rock pigeon, they must have descended from at least 7 or 8 aboriginal stocks, for it is impossible to make the present domestic breeds by the crossing of any lesser number. How, for instance, could a pouter be produced by crossing 2 breeds, unless one of the parent stocks possessed the characteristic enormous crop? The supposed aboriginal stocks must all have been rock pigeons, that is, they did not breed or willingly perch on trees. But besides Columba livia, with its geographical subspecies, only 2 or 3 other species of rock pigeons are known, and these have not any of the characters of the domestic breeds. Hence, the supposed aboriginal stocks must either still exist in the countries where they were originally domesticated, and yet be unknown to ornithologists, and this, considering their size, habits, and remarkable characters, seems improbable, or they must have become extinct in the wild state. But birds breeding on precipices and good flyers are unlikely to be exterminated, and the common rock pigeon, which has the same habits with the domestic breeds, has not been exterminated even on several of the smaller British islets, or on the shore of the Mediterranean. Hence the supposed extermination of so many species having similar habits with the rock pigeon seems a very rash assumption. Moreover, the several above-named domesticated breeds have been transported to all parts of the world, and therefore some of them must have been carried back again into their native country, but not one has become wild or feral, though the dovecot pigeon, which is the rock pigeon in a very slightly altered state, has become feral in several places. Again, all recent experience shows that it is difficult to get wild animals to breed freely under domestication. Yet, on the hypothesis of the multiple origin of our pigeons, it must be assumed that at least 7 or 8 species were so thoroughly domesticated in ancient times by half-civilized man as to be quite prolific under confinement. An argument of great weight, and applicable in several other cases, is that the above-specified breeds, though agreeing generally with the wild rock pigeon in constitution, habits, voice, coloring, and in most parts of their structure, yet are certainly highly abnormal in other parts, we may look in vain through the whole family of Columbidae for a beak like that of the English carrier, or that of the short-faced tumbler or barb, for reversed feathers like those of the Jacobin, for a crop like that of the pouter, for tail feathers like those of the fantail. Hence it must be assumed not only that half-civilized man succeeded in thoroughly domesticating several species, but that he intentionally or by chance picked out extraordinarily abnormal species, and further, that these very species have since all become extinct or unknown. So many strange contingencies are improbable in the highest degree. Some facts in regard to the coloring of pigeons well deserve consideration. The rock pigeon is of a slaty blue, with white loins, but the Indian subspecies, Columba intermedia of Strickland, has this part bluish. The tail has a terminal dark part, with the outer feathers externally edged at the base with white. The wings have 2 black bars. Some semi-domestic breeds, and some truly wild breeds, have, besides the 2 black bars, the wings checkered with black. These several marks do not occur together in any other species of the whole family. Now, in every one of the domestic breeds, taking thoroughly well-bred birds, all the above marks, even to the white edging of the outer tail feathers, sometimes concur perfectly developed. Moreover, when birds belonging to 2 or more distinct breeds are crossed, none of which are blue or have any of the above specified marks, the mongrel offspring are very apt suddenly to acquire these characters. To give one instance out of several which I have observed, I crossed some white fantails, which breed very true, with some black barbs, and it so happens that blue varieties of barbs are so rare that I never heard of an instance in England, and the mongrels were black, brown, and mottled. I also crossed a barb with a spot, which is a white bird with a red tail and red spot on the forehead, and which notoriously breeds very true. The mongrels were dusky and mottled. I then crossed one of the mongrel barb fantails with a mongrel barb spot, and they produced a bird of as beautiful a blue color, with the white loins, double black wing bar, and barred and white-edged tail feathers, as any wild rock pigeon. We can understand these facts on the well-known principle of reversion to ancestral characters, if all the domestic breeds are descended from the rock pigeon. But if we deny this, we must make one of the 2 following highly improbable suppositions. Either first, that all of the several imagined aboriginal stocks were colored and marked like the rock pigeon, although no other existing species is thus colored and marked, so that in each separate breed there might be a tendency to revert to the very same colors and markings. Or secondly, that each breed, even the purest, has within a dozen, or at most within a score, of generations, been crossed by the rock pigeon. I say within a dozen or 20 generations, for no instance is known of crossed descendants reverting to an ancestor of foreign blood, removed by a greater number of generations. In a breed which has been crossed only once, the tendency to revert to any character derived from such a cross will naturally become less and less, as in each succeeding generation there will be less of the foreign blood. But when there has been no cross, and there is a tendency in the breed to revert to a character which was lost during some former generation, this tendency, for all that we can see to the contrary, may be transmitted undiminished for an indefinite number of generations. These 2 distinct cases of reversion are often confounded together by those who have written on inheritance. Lastly, the hybrids or mongrels from between all the breeds of the pigeon are perfectly fertile, as I can state from my own observations, purposely made on the most distinct breeds. Now, hardly any cases have been ascertained with certainty of hybrids from two quite distinct species of animals being perfectly fertile. Some authors believe that long-continued domestication eliminates this strong tendency to sterility in species. From the history of the dog, and of some other domestic animals, this conclusion is probably quite correct, if applied to species closely related to each other. But to extend it so far as to suppose that species, aboriginally as distinct as carriers, tumblers, pouters, and fantails now are, should yield offspring perfectly fertile inter se, seems to me rash in the extreme. From these several reasons, namely, the improbability of man having formerly made 7 or 8 supposed species of pigeons to breed freely under domestication, these supposed species being quite unknown in a wild state, and their not having become anywhere feral, these species presenting certain very abnormal characters, as compared with all other Columbidae, though so like the rock pigeon in most other respects, the occasional reappearance of the blue color and various black marks in all the breeds, both when kept pure and when crossed, and lastly the mongrel offspring being perfectly fertile, from these several reasons taken together, we may safely conclude that all our domestic breeds are descended from the rock pigeon, or Columba livia, with its geographical subspecies. In favor of this view, I may add, firstly, that the wild Columba livia has been found capable of domestication in Europe and in India, and that it agrees in habitats and in a great number of points of structure with all the domestic breeds. Secondly, that although an English carrier or a short-faced tumbler differs immensely in certain characters from the rock pigeon, yet that by comparing the several subbreeds of these two races, more especially those brought from distant countries, we can make between them and the rock pigeon an almost perfect series, so we can in some other cases, but not with all the breeds. Thirdly, those characters which are mainly distinctive of each breed are in each eminently variable. For instance, the wattle and length of beak of the carrier, the shortness of that of the tumbler, and the number of tail feathers in the fantail, and the explanation of this fact will be obvious when we treat of selection. Fourthly, pigeons have been watched and tended with the utmost care and loved by many people. They have been domesticated for thousands of years in several quarters of the world. The earliest known record of pigeons is in the 5th Egyptian dynasty, about 3000 B.C., as was pointed out to me by Professor Lepsius, but Mr. Birch informs me that pigeons are given in a bill of fare in the previous dynasty. In the time of the Romans, as we hear from Pliny, immense prices were given for pigeons. Nay, they are come to this pass, that they can reckon up their pedigree and race. Pigeons were much valued by Akbar Khan in India, about the year 1600. Never less than 20,000 pigeons were taken with the court. The monarchs of Iran and Turan sent him some very rare birds, and, continues the courtly historian, His Majesty, by crossing the breeds, which method was never practiced before, has improved them astonishingly. About this same period the Dutch were as eager about pigeons as were the old Romans. The paramount importance of these considerations in explaining the immense amount of variation which pigeons have undergone will likewise be obvious when we treat of selection. We shall then also see how it is that the several breeds so often have a somewhat monstrous character. It is also a most favorable circumstance for the production of distinct breeds that male and female pigeons can be easily mated for life, and thus different breeds can be kept together in the same aviary. I have discussed the probable origin of domestic pigeons at some, yet quite insufficient length, because when I first kept pigeons and watched the several kinds, well knowing how truly they breed, I felt fully as much difficulty in believing that since they had been domesticated, they had all proceeded from a common parent, as any naturalist could in coming to a similar conclusion in regard to the many species of finches or other groups of birds in nature. One circumstance has struck me much, namely, that nearly all the breeders of the various domestic animals and the cultivators of plants with whom I have conversed, or whose treatises I have read, are firmly convinced that the several breeds to which each has attended are descended from so many aboriginally distinct species. Ask, as I have asked, a celebrated raiser of Hereford cattle, whether his cattle might not have descended from longhorns, or both from a common parent stock, and he will laugh you to scorn. I have never met a pigeon, or poultry, or duck, or rabbit fancier, who is not fully convinced that each main breed was descended from a distinct species. Van Mons, in his treatise on pears and apples, shows how utterly he disbelieves that the several sorts, for instance a Ribston pippin or codlin apple, could ever have proceeded from the seeds of the same tree. Innumerable other examples could be given. The explanation, I think, is simple. From long-continued study they are strongly impressed with the differences between the several races, and though they well know that each race varies slightly, for they win their prizes by selecting such slight differences, yet they ignore all general arguments, and refuse to sum up in their minds slight differences accumulated during many successive generations. May not those naturalists, who, knowing far less of the laws of inheritance than does the breeder, and knowing no more than he does of the intermediate links in the long lines of descent, yet admit that many of our domestic races are descended from the same parents, may they not learn a lesson of caution when they deride the idea of species in a state of nature being lineal descendants of other species? Principles of selection anciently followed, and their effects. Let us now briefly consider the steps by which domestic races have been produced, either from one or from several allied species. Some effect may be attributed to the direct and definite action of the external conditions of life, and some to habit, but he would be a bold man who would account by such agencies for the differences between a dray and racehorse, a greyhound and bloodhound, a carrier and tumbler pigeon. One of the most remarkable features in our domesticated races is that we see in them adaptation, not indeed to the animal's or plant's own good, but to man's use or fancy. Some variations useful to him have probably arisen suddenly, or by one step. Many botanists, for instance, believe that the fuller's teasel, with its hooks, which cannot be rivaled by any mechanical contrivance, is only a variety of the wild dipsacus, and this amount of change may have suddenly arisen in a seedling. So it has probably been with the turnspit dog, and this is known to have been the case with the Ancon sheep. But when we compare the dray horse and racehorse, the dromedary and camel, the various breeds of sheep fitted either for cultivated land or mountain pasture, with the wool of one breed good for one purpose, and that of another breed for another purpose, when we compare the many breeds of dogs, each good for man in different ways, when we compare the gamecock, so pertinacious in battle, with other breeds so little quarrelsome, with everlasting layers which never desire to sit, and with the bantam so small and elegant, when we compare the host of agricultural, culinary, orchard, and flower garden races of plants, most useful to man at different seasons and for different purposes, or so beautiful in his eyes, We must, I think, look further than to mere variability. We cannot suppose that all the breeds were suddenly produced as perfect and as useful as we now see them. Indeed, in many cases we know that this has not been their history. The key is man's power of accumulative selection. Nature gives successive variations. Man adds them up in certain directions useful to him. In this sense, he may be said to have made for himself useful breeds. The great power of this principle of selection is not hypothetical. It is certain that several of our eminent breeders have, even within a single lifetime, modified to a large extent their breeds of cattle and sheep. In order fully to realize what they have done, it is almost necessary to read several of the many treatises devoted to this subject, and to inspect the animals. Breeders habitually speak of an animal's organization as something plastic, which they can model almost as they please. If I had space, I could quote numerous passages to this effect from highly competent authorities. Youatt, who is probably better acquainted with the works of agriculturalists than almost any other individual, and who was himself a very good judge of animals, speaks of the principle of selection as that which enables the agriculturalist not only to modify the character of his flock, but to change it altogether. It is the magician's wand, by means of which he may summon into life whatever form and mold he pleases. Lord Somerville, speaking of what breeders have done for sheep, says, "It would seem as if they had chalked out upon a wall a form perfect in itself, and then had given its existence." In Saxony, the importance of the principle of selection in regard to merino sheep is so fully recognized that men follow it as a trade. The sheep are placed on a table and are studied, like a picture by a connoisseur. This is done 3 times at intervals of months, and the sheep are each time marked and classed, so that the very best may ultimately be selected for breeding. What English breeders have actually effected is proved by the enormous prices given for animals with a good pedigree, and these have been exported to almost every quarter of the world. The improvement is by no means generally due to crossing different breeds. All the best breeders are strongly opposed to this practice, except sometimes among closely allied sub-breeds, and when a cross has been made, the closest selection is far more indispensable even than in ordinary cases. If selection consisted merely in separating some very distinct variety and breeding from it, the principle would be so obvious as hardly to be worth notice. But its importance consists in the great effect produced by the accumulation in one direction, during successive generations, of differences absolutely inappreciable by an uneducated eye, differences which I, for one, have vainly attempted to appreciate. Not one man in 1,000 has accuracy of eye and judgment sufficient to become an eminent breeder. If gifted with these qualities, and he studies his subject for years, and devotes his lifetime to it with indomitable perseverance, he will succeed, and may make great improvements. If he wants any of these qualities, he will assuredly fail. Few would readily believe in the natural capacity and years of practice requisite to become even a skillful pigeon fancier. The same principles are followed by horticulturalists, but the variations are here often more abrupt. No one supposes that our choicest productions have been produced by a single variation from the aboriginal stock. We have proofs that this is not so in several cases in which exact records have been kept. Thus, to give a very trifling instance, the steadily increasing size of the common gooseberry may be quoted. We see an astonishing improvement in many florists' flowers, when the flowers of the present day are compared with drawings made only 20 or 30 years ago. When a race of plants is once pretty well established, The seed raisers do not pick out the best plants, but merely go over their seed beds and pull up the rogues, as they call the plants that deviate from the proper standard. With animals, this kind of selection is, in fact, likewise followed, for hardly anyone is so careless as to breed from his worst animals. In regard to plants, there is another means of observing the accumulated effects of selection, namely, by comparing the diversity of flowers in the different varieties of the same species in the flower garden, the diversity of leaves, pods, or tubers, or whatever part is valued in the kitchen garden, in comparison with the flowers of the same varieties, and the diversity of fruit of the same species in the orchard, in comparison with the leaves and flowers of the same set of varieties. See how different the leaves of the cabbage are, and how extremely alike the flowers, how unlike the flowers of the heartsease are, and how alike the leaves, how much the fruit of the different kinds of gooseberries differ in size, color, shape, and hairiness, and yet the flowers present very slight differences. It is not that the varieties which differ largely in some one point do not differ at all in other points. This is hardly ever, I speak after careful observation, perhaps never, the case. The law of correlated variation, the importance of which should never be overlooked, will ensure some differences. But as a general rule, it cannot be doubted that the continued selection of slight variations, either in the leaves, the flowers, or the fruit, will produce races differing from each other, chiefly in these characters. It may be objected that the principle of selection has been reduced to methodical practice for scarcely more than 3/4 of a century. It has certainly been more attended to of late years, and many treatises have been published on the subject, and the result has been, in a corresponding degree, rapid and important. But it is very far from true that the principle is a modern discovery. I could give several references to works of high antiquity in which the full importance of the principle is acknowledged. In rude and barbarous periods of English history, choice animals were often imported, and laws were passed to prevent their exportation. The destruction of horses under a certain size was ordered, and this may be compared to the roguing of plants by nurserymen. The principle of selection I find distinctly given in an ancient Chinese encyclopedia. Explicit rules are laid down by some of the Roman classical writers. From passages in Genesis, it is clear that the color of domestic animals was at that early period attended to. Savages now sometimes cross their dogs with wild canine animals to improve the breed, and they formerly did so, as is attested by passages in Pliny. The savages in South Africa match their draft cattle by color, as do some of the Eskimo their teams of dogs. Livingstone states that good domestic breeds are highly valued by the Negroes in the interior of Africa, who have not associated with Europeans. Some of these facts do not show actual selection, but they show that the breeding of domestic animals was carefully attended to in ancient times, and is now attended to by the lowest savages. It would indeed have been a strange fact, had attention not been paid to breeding, for the inheritance of good and bad qualities is so obvious. Unconscious selection. At the present time, eminent breeders try, by methodical selection, with a distinct object in view, to make a new strain or sub-breed superior to anything of the kind in the country. But for our purpose, a form of selection which may be called unconscious, and which results from everyone trying to possess and breed from the best individual animals, is more important. Thus, a man who intends keeping pointers naturally tries to get as good dogs as he can, and afterwards breeds from his own best dogs. But he has no wish or expectation of permanently altering the breed. Nevertheless, we may infer that this process, continued during centuries, would improve and modify any breed, in the same way as Bakewell, Collins, etc., by this very same process, only carried on more methodically, did greatly modify, even during their lifetimes, the forms and qualities of their cattle. Slow and insensible changes of this kind could never be recognized unless actual measurements or careful drawings of the breeds in question have been made long ago, which may serve for comparison. In some cases, however, unchanged or but little changed, individuals of the same breed exist in less civilized districts, where the breed has been less improved. There is reason to believe that King Charles's Spaniel has been unconsciously modified to a large extent since the time of that monarch. Some highly competent authorities are convinced that the setter is directly derived from the Spaniel, and has probably been slowly altered from it. It is known that the English Pointer has been greatly changed within the last century, and in this case the change has, it is believed, been chiefly effected by crosses with the foxhound. But what concerns us is that the change has been effected unconsciously and gradually, and yet so effectually that, though the old Spanish Pointer certainly came from Spain, Mr. Barrow has not seen, as I am informed by him, any native dog in Spain like our Pointer. By a similar process of selection, and by careful training, English racehorses have come to surpass in fleetness and size the parent Arabs, so that the latter, by the regulations for the Goodwood races, are favored in the weights which they carry. Lord Spencer and others have shown how the cattle of England have increased in weight and in early maturity, compared with the stock formerly kept in this country. By comparing the accounts given in various old treatises of the former and present state of carrier and tumbler pigeons in Britain, India, and Persia, we can trace the stages through which they have insensibly passed, and come to differ so greatly from the rock pigeon. Youatt gives an excellent illustration of the effects of a course of selection which may be considered as unconscious, in so far that the breeders could never have expected, or even wished, to produce the results which ensued, namely, the production of the distinct strains. The 2 flocks of Leicester sheep, kept by Mr. Buckley and Mr. Burgess, as Mr. Youatt remarks, have been purely bred from the original stock of Mr. Bakewell for upwards of 50 years. There is not a suspicion existing in the mind of any one at all acquainted with the subject that the owner of either of them has deviated in any one instance from the pure blood of Mr. Bakewell's flock, and yet the difference between the sheep possessed by these 2 gentlemen is so great that they have the appearance of being quite different varieties. If there exist savages so barbarous as never to think of the inherited character of the offspring of their domestic animals, yet any one animal particularly useful to them for any special purpose would be carefully preserved during famines and other accidents to which savages are so liable, and such choice animals would thus generally leave more offspring than the inferior ones, so that in this case there would be a kind of unconscious selection going on. We see the value set on animals even by the barbarians of Tierra del Fuego, by their killing and devouring their old women in times of dearth, as of less value than their dogs. In plants, the same gradual process of improvement through the occasional preservation of the best individuals, whether or not sufficiently distinct to be ranked at their first appearance as distinct varieties, and whether or not 2 or more species or races have become blended together by crossing, may plainly be recognized in the increased size and beauty which we now see in the varieties of the heartsease, rose, pelargonium, dahlia, and other plants, and when compared with the older varieties or with their parent stocks. No one would ever expect to get a first-rate heartsease or dahlia from the seed of a wild plant. No one would expect to raise a first-rate melting pear from the seed of a wild pear, though he might succeed from a poor seedling growing wild if it had come from a garden stock. The pear, though cultivated in classical times, appears, from Pliny's description, to have been a fruit of very inferior quality. I have seen great surprise expressed in horticultural works at the wonderful skill of gardeners in having produced such splendid results from such poor materials. But the art has been simple, and as far as the final result is concerned, has been followed almost unconsciously. It has consisted in always cultivating the best-known variety, sowing its seeds, and, when a slightly better variety chanced to appear, selecting it, and so onwards. But the gardeners of the classical period, who cultivated the best pears which they could procure, never thought what splendid fruit we should eat, though we owe our excellent fruit, in some small degree, to their having naturally chosen and preserved the best varieties they could anywhere find. A large amount of change, thus slowly and unconsciously accumulated, explains, as I believe, the well-known fact that in a number of cases we cannot recognize, and therefore do not know, the wild parent stocks of the plants which have been longest cultivated in our flower and kitchen gardens. If it has taken centuries or thousands of years to improve or modify most of our plants up to their present standard of usefulness to man, we can understand how it is that neither Australia, the Cape of Good Hope, nor any other region inhabited by quite uncivilized man, has afforded us a single plant worth culture. It is not that these countries, so rich in species, do not by a strange chance possess the aboriginal stocks of any useful plants, but that the native plants have not been improved by continued selection up to a standard of perfection comparable with that acquired by the plants in countries anciently civilized. In regard to the domestic animals kept by uncivilized man, it should not be overlooked that they almost always have to struggle for their own food, at least during certain seasons. And in two countries very differently circumstanced, individuals of the same species, having slightly different constitutions or structure, would often succeed better in the one country than in the other, and thus, by a process of natural selection, as will hereafter be more fully explained, two sub-breeds might be formed. This perhaps partly explains why the varieties kept by savages, as has been remarked by some authors, have more of the character of true species than the varieties kept in civilized countries. On the view here given of the important part which selection by man has played, it becomes at once obvious how it is that our domestic races show adaptation in their structure, or in their habits, to man's wants or fancies. We can, I think, further understand the frequently abnormal character of our domestic races, and likewise their differences being so great in external characters, and relatively so slight in internal parts or organs. Man can hardly select, or only with much difficulty, any deviation of structure, excepting such as is externally visible, and indeed he rarely cares for what is internal. He can never act by selection, excepting on variations which are first given to him in some slight degree by nature. No man would ever try to make a fantail till he saw a pigeon with a tail developed in some slight degree in an unusual manner, or a pouter till he saw a pigeon with a crop of somewhat unusual size. And the more abnormal or unusual any character was when it first appeared, the more likely it would be to catch his attention. But to use such an expression as trying to make a fantail is, I have no doubt, in most cases utterly incorrect. The man who first selected a pigeon with a slightly larger tail never dreamed what the descendants of that pigeon would become through long-continued, partly unconscious and partly methodical, selection. Perhaps the parent bird of all fantails had only 14 tail feathers, somewhat expanded, like the present Java fantail, or like individuals of other and distinct breeds, in which as many as 17 tail feathers have been counted. Perhaps the first pouter pigeon did not inflate its crop much more than the turbot now does the upper part of its esophagus, a habit which is disregarded by all fanciers, as it is not one of the points of the breed. Nor let it be thought that some great deviation of structure would be necessary to catch the fancier's eye. He perceives extremely small differences, and it is in human nature to value any novelty, however slight, in one's own possession. Nor must the value which would formerly have been set on any slight differences in the individuals of the same species be judged of by the value which is now set on them after several breeds have fairly been established. It is known that with pigeons many slight variations now occasionally appear, that these are rejected as faults or deviations from the standard of perfection in each breed. The common goose has not given rise to any marked varieties. Hence the Toulouse and the common breed, which differ only in color, that most fleeting of characters, have lately been exhibited as distinct at our poultry shows. These views appear to explain what has sometimes been noticed, namely, that we know hardly anything about the origin or history of any of our domestic breeds. But, in fact, a breed, like a dialect of a language, can hardly be said to have a distinct origin. A man preserves and breeds from an individual with some slight deviation of structure, or takes more care than usual in matching his best animals, and thus improves them, and the improved animals slowly spread in the immediate neighborhood. But they will as yet hardly have a distinct name, and from being only slightly valued, their history will have been disregarded. When further improved by the same slow and gradual process, they will spread more widely, and will be recognized as something distinct and valuable, and will then probably first receive a provincial name. In semi-civilized countries, with little free communication, the spreading of a new sub-breed will be a slow process. As soon as the points of value are once acknowledged, the principle, as I have called it, of unconscious selection will always tend, perhaps more at one period than at another, as the breed rises or falls in fashion, perhaps more in one district than in another, according to the state of civilization of the inhabitants, slowly to add to the characteristic features of the breed, whatever they may be. But the chance will be infinitely small of any record having been preserved of such slow, varying, and insensible changes. Circumstances favorable to man's power of selection. I will now say a few words on the circumstances, favorable or the reverse, to man's power of selection. A high degree of variability is obviously favorable, as freely giving the materials for selection to work on. Not that mere individual differences are not amply sufficient, with extreme care, to allow of the accumulation of a large amount of modification in almost any desired direction. But as variations manifestly useful or pleasing to man appear only occasionally, the chance of their appearance will be much increased by a large number of individuals being kept. Hence, number is of the highest importance for success. On this principle, Marshall formerly remarked with respect to the sheep of part of Yorkshire, as they generally belong to poor people and are mostly in small lots, they never can be improved. On the other hand, nurserymen, from keeping large stocks of the same plant, are generally far more successful than amateurs in raising new and valuable varieties. A large number of individuals of an animal or plant can be reared only where the conditions for its propagation are favorable. When the individuals are scanty, All will be allowed to breed, whatever their quality may be, and this will effectually prevent selection. But probably the most important element is that the animal or plant should be so highly valued by man that the closest attention is paid to even the slightest deviations in its qualities or structure. Unless such attention be paid, nothing can be effected. I have seen it gravely remarked that it was most fortunate that the strawberry began to vary just when gardeners began to attend to this plant. No doubt the strawberry had always varied since it was cultivated, but the slight varieties had been neglected. As soon, however, as gardeners picked out individual plants with slightly larger, earlier, or better fruit, and raised seedlings from them, and again picked out the best seedlings and bred from them, then, with some aid by crossing distinct species, those many admirable varieties of the strawberry were raised which have appeared during the last half-century. With animals, facility in preventing crosses is an important element in the formation of new races, at least in a country which is already stocked with other races. In this respect, enclosure of the land plays a part. Wandering savages or the inhabitants of open plains rarely possess more than one breed of the same species. Pigeons can be mated for life, and this is a great convenience to the fancier, for thus many races may be improved and kept true, though mingled in the same aviary, and this circumstance must have largely favored the formation of new breeds. Pigeons, I may add, can be propagated in great numbers and at a very quick rate, and inferior birds may be freely rejected, as when killed they serve for food. On the other hand, cats, from their nocturnal rambling habits, cannot be easily matched, and, although so much valued by women and children, we rarely see a distinct breed long kept up. Such breeds as we do sometimes see are almost always imported from some other country. Although I do not doubt that some domestic animals vary less than others, yet the rarity or absence of distinct breeds of the cat, the donkey, peacock, goose, etc., may be attributed in main part to selection not having been brought into play. In cats, for the difficulty in pairing them. In donkeys, from only a few being kept by poor people, and little attention paid to their breeding. For recently in certain parts of Spain and of the United States, this animal has been surprisingly modified and improved by careful selection. In peacocks, from not being very easily reared, and a large stock not kept. In geese, from being valuable only for two purposes, food and feathers, and more especially from no pleasure having been felt in the display of distinct breeds. But the goose, under the conditions to which it is exposed when domesticated, seems to have a singularly inflexible organization, though it has varied to a slight extent, as I have elsewhere described. Some authors have maintained that the amount of variation in our domestic productions is soon reached, and can never afterward be exceeded. It would be somewhat rash to assert that the limit has been attained in any one case, for almost all our animals and plants have been greatly improved in many ways within a recent period, and this implies variation. It would be equally rash to assert that characters, now increased to their utmost limit, could not, after remaining fixed for many centuries, again vary under new conditions of life. No doubt, as Mr. Wallace has remarked with much truth, a limit will be at last reached. For instance, there must be a limit to the fleetness of any terrestrial animal, as this will be determined by the friction to be overcome, the weight of the body to be carried, and the power of contraction in the muscular fibers. But what concerns us is that the domestic varieties of the same species differ from each other in almost every character, which man has attended to and selected, more than do the different species of the same genera. Isidore Geoffroy Saint-Hilaire has proved this in regard to size, and so it is with color, and probably with the length of hair. With respect to fleetness, which depends on many bodily characters, Eclipse was far fleeter, and a dray horse is comparably stronger than any two natural species belonging to the same genus. So with plants, the seeds of the different varieties of the bean or maize probably differ more in size than do the seeds of the distinct species in any one genus in the same two families. The same remark holds good in regard to the fruit of the several varieties of the plum, and still more strongly with the melon, as well as in many other analogous cases. To sum up on the origin of our domestic races of animals and plants. Changed conditions of life are of the highest importance in causing variability, both by acting directly on the organization and indirectly by affecting the reproductive system. It is not probable that variability is an inherent and necessary contingent under all circumstances. The greater or less force of inheritance and reversion determine whether variations shall endure. Variability is governed by many unknown laws, of which correlated growth is probably the most important. Something, but how much we do not know, may be attributed to the definite action of the conditions of life. Some, perhaps a great, effect may be attributed to the increased use or disuse of parts. The final result is thus rendered infinitely complex. In some cases, the intercrossing of aboriginally distinct species appears to have played an important part in the origin of our breeds. When several breeds have once been formed in any country, their occasional intercrossing, with the aid of selection, has no doubt largely aided in the formation of new sub-breeds. But the importance of crossing has been much exaggerated, both in regard to animals and to those plants which are propagated by seed. With plants which are temporarily propagated by cuttings, buds, etc., the importance of crossing is immense, for the cultivator may here disregard the extreme variability both of hybrids and of mongrels, and the sterility of hybrids. But plants not propagated by seed are of little importance to us, for their endurance is only temporary. Over all these causes of change, the accumulative action of selection, whether applied methodically and quickly, or unconsciously and slowly, but more efficiently, seems to have been the predominant power. End of Chapter 1, Part B.